In this video, we're going to look at the idea of graphing. So consider the following scenario where a 14-inch candle is lit and steadily burns until it is burned out. I have that shown over here on this applet to the left. So we can imagine the candle burning down, and we'll let the variable b represent the burned length of the candle in inches, and we'll let r represent the remaining length of the candle in inches. So we have these segments over here representing the burned and remaining length, but over on the right-hand side, we also have some horizontal segments representing the values of r and b. We're just putting them horizontal so it's a little easier for us to compare them. Now, as the candle burns, both of those segments vary in length because b and r vary in value. So we notice that as the candle burns, b gets larger and r gets smaller. Now what we'll do is, instead of having those segments for b and r represented horizontally, we'll make r vertical, and then we'll place those two segments end to end, as shown over here on this right-hand side. So then as the candle burns, those segments vary in the same way, but now r is vertical and b is still horizontal. So as the candle burns, b gets larger, r gets smaller, but now we have them like perpendicular to one another. So to coordinate these two quantities, what we'll do is take a point and we'll place it so that its horizontal component lines up with the value of b, and the vertical component lines up with the value of r. So notice that as the candle burns, that point moves so that its horizontal component gives us the value of b, and the vertical component gives us the value of r. So as the candle burns, it looks like the point is moving downwards and to the right, but that's because b is getting larger and r is getting smaller. So to make it a little easier to tell what the values of b and r are, we put those segments representing b and r onto a set of axes. So we have a horizontal axis representing the value of b and a vertical one representing the value of r, and then those segments, they vary in length, but like right now we can see that b, that segment representing the value of b, has a value of 10 because that's where we are on that horizontal axis, and similarly r has a value of 4 just by looking at the length of that thing on the vertical axis. So not much has changed here. We just have a set of axes that makes it a little easier for us to tell the values of b and r at any point in time. So then what we'll do is, as this candle burns, we're going to trace that point that represents the simultaneous values of b and r. So we'll imagine the candle burning, but now we're going to trace that point, and as the candle burns, that point traces out a curve, or a line in this case, and that line, which is really a graph, represents all possible pairs of values of b and r. So that graph gives us like a record of how b and r were related as the candle burned. Let's see how we might use this. So we have the graph of r in terms of b shown here, and we notice that the point 3.5, 10.5 is on this graph, which really tells us that at some moment in time, the value of b is 3.5, and the value of r is 10.5. Or that tells us that at some moment the burned length of the candle is 3.5 inches, and the remaining length of the candle is 10.5 inches. On the other hand, we could say that when 12 inches have burned from the candle, or b equals 12, the remaining length of the candle is 2 inches, or r equals 12, and so we could plot a point at 12, 2, to represent that simultaneous value of b and r.